organized and try your best to put it together exactly as the drawings show. If you have questions, you can't decipher something, then what you do is you get me involved. Okay, and then we'll both look at them and we'll try and figure out what's going on and put it together. Ultimately, you will never be asked about your project. Okay. We'll then take it out to the bridge and throw it off. You throw off however you receive it back from the person that was assembling it. Okay.
Oh, so you throw your own, not the person that assembled.
Yeah, you can throw your own.
Oh, so we don't have to
Not
have, like,
throw,
dropping
gently
instructions?
let float.
Yes, Kate?
So we don't have to have like dropping instructions and direction stuff because we're doing that.
Yes, you'll drop it yourself. Okay. Yeah, if you got a specific side it needs to hit or how you want it to start, you'll have control over that. Okay. I will provide the eggs, so we don't need to have those. And I think that's it. Does anybody have like glue guns or anything of that necessary? You do? Okay. You need to make sure you bring that in.
Oh, no, I thought you wanted someone to bring, no, I don't have it for my project.
Oh, okay.
I need it, I can bring it for you. Crafty, you got them too, I'm sure.
No.
Crafty kid.
Oh, yeah.
No, if you have it, you provide.
Oh, yeah, no, I don't need it.
Okay. All right, so here's what you're to bring. Starting at the top, provide the following in a box, sacks, or other container. This is for the other person to assemble. All parts as drawn in your detailed drawings. Now, you may or may not need your detailed drawings. Okay, but if you got an assembly drawing and you have two parts that are very similar, you may want to provide the detailed drawings. Like let's say you're using a couple pieces of tape, but one's 6 inches, one's 8 inches, and you need them in a specific place. Then you may want to put the detailed drawing saying, maybe you got it labeled small tape and large tape. And then the detailed drawing would have the dimensions showing the size of it. Okay. So depending on if you think you need the details or not, they're not required, but it's always a good idea to include them so that they can look at it and see the dimensions and match it up specifically with the part. Okay. You may want to label them, number or name. Okay, and I've got a whole bunch of little sticky tabs back in my office if you want to borrow them, you know. Maybe this is part A, this is part B, whatever. You can just take a sticky, stick it on there, and label it. This is A. Okay, and it comes on the part. Okay, that's real common. So you can add that to help identify parts. Second one, your copies of details and assemblies. And we already talked about the details. The assembly drawings, I'm assuming, will be necessary. So you will want to provide an extra copy for them. Printed assembly instructions. You may have these in Word that are separate from them. You may have the assembly instructions just using MText right on the drawing. Any of those are sufficient. Just make sure that they're, labeled assembly instructions so that a person can read through them. When you get yours, I would really highly encourage you to read them completely through before you start assembling. Again, treat it like it was your own.
Wait, question. Are we making a separate copy of this for them? We're not giving them our actual report, or our actual final copy?
Well, typically we do a second copy so you don't have to reassemble your report.
Okay.
But if you want to just hand them your report, if everything's in there, that would work too. Either or. It saves some paper if you did that.
Oh, okay.
Now for the proposal, that's on the bottom part, and everything in here is already listed in your original project packet. So your cover page, table of contents, proposal, assembly drawings, detailed drawings, assembly instructions, which may be included with the assemblies. If it's separate, put it after the drawings. Bill of materials with your cost analysis. And again, if you have any problems with that, please get me involved. If you haven't ever used Excel really and not sure how to do that, then
How
yes.
much are our eggs going to cost?
What's that?
How much are our eggs going to cost?
They're free.
Oh.
Your eggs are free.
If they're real, are they your homegrown chickens? They have tougher shells.
Yeah, and I've actually been feeding them seashells lately, so
Nice,
they're
good calendar, that's awesome.
They got lots of calcium now.
Okay.
I'm thinking of you folks.
Thank you.
and any appendix that you might have. Now, your appendix certainly will have your notes that you've taken to establish patent, idea, creation, and timeline. And again, we talked about that yesterday. You can just slip all that in the manila folder and stick it at the end of the report. And I think that's about it. Yes, sure.
Just out of curiosity, do the printed assembly instructions that we give to the student, do they have to be identical to what's in the report?
So what's in the report? Yeah, they should be. They should be the same thing. If you feel like you have to add something for what we're doing, then they probably should be added to the report also. Now,
Like a last minute, oh my gosh, I forgot to put this in, and you write it in on there.
yeah, your report will be due Friday.
Okay.
So if you do have that happen, then just handwrite it in because you won't have time to change it, and we'll do it and then fix your report to match that. Okay. Again, I'd highly encourage you folks, find the least mechanical person you know and hand them those assembly instructions and a bag of stuff and see if they can put it together. You'll find your holes in your assembly instructions and or drawings very quickly. Yes, sir.
I have another question. So I actually have a needle included with mine that's not a part of the assembly. Should that be a part, or should it just be,
Well, it's not in the assembly, why would you use it?
right? I mean, is it included as a part even though it's not used in the final product? It's used to assemble it?
Oh,
Assembly.
no, you should not have a drawing of that.
Okay.
Okay, but it would be in your assembly instructions saying use needle tool to put provided needle tool
Okay.
or whatever to put this
Sewing
together.
something?
So is it what, kind of like a knitting needle or?
Well, it's
Not a
crochet.
big long
It's a,
hypodermic,
it's
is
about
it?
that long.
Crochet needle.
It's about that long and it's made out of duct tape.
Okay.
Okay, and then, yeah, just
Okay.
provide the tool and mention it in your assembly instructions. That should be all you need.
Okay.
Okay. All right, so there's kind of your checklist to get yourself ready. All right, chapter 19 is a fairly big chapter. I want to take it in 2 days. So today we're just going to talk really a little about the theory and history of threaded fasteners and what we use them for. Although really what we're not really talking about besides threaded fasteners is just how do we join parts. Okay. And then tomorrow I've got another handout that goes with it that I want you to use. And we'll go into the terminology and how to draw. Now, certainly, we've already gone over the simplified method of how to draw, but there are 2 other representations we use on drawings. One is a schematic representation, the other is the, the actual thread representation. So we'll cover those tomorrow, and we'll do some drawing as a group so that you see how to do these. So first off, when we look at chapter 19, it's labeled Fastening Devices and Methods. And when we think of fastening, really I want you to think of it 2 ways. We have what we call a permanent fastener and a temporary fastener. I have no idea if I spelled either of those wrong. What's the difference between the 2?
One can be removed and one you gotta break.
There you go. Okay. Yeah, one can be, you can remove, one you can't. And in fact, really what we think about is if I have a permanent fastener, I must destroy the fastener or the part to get them apart. If I have a temporary fastener, nothing is broken as I take it apart. Okay. In essence, why would we use a temporary or a permanent? There's really only one reason.
Well, it's how likely it's going to be removed.
Yeah.
Or how great.
Exactly. So we would call that maintenance, right? Do I need to perform maintenance on the part or not? Many times we do, many times we don't. Keep that in mind. Now, a lot of times you could use a temporary fastener to get something back apart. But if it's a very cheap part and it costs you this cents to make, it might be cheaper to throw it away and use a permanent fastener than it would be to take it apart and replace it.
So it breaks, you have to buy a new one.
Yeah, because remember, if you're gonna provide maintenance on it, you've now got a skilled technician working on that, and that costs money to get those people going. So if I'm paying somebody 20 bucks an hour and I have to disassemble something that costs 3 cents, hey, I'm losing a lot of money, right? And so then I would just throw it away and put a new one in. Now, a lot of parts get much more expensive, and we do want to save those parts. Or maybe, in the case of your car engine, that's obviously a very expensive part. I think most engines now are right around $2,000. Okay? So that's worthwhile fixing that and taking certain components off of it and replacing them. What would be examples of these? Let's talk about permanent fastening. What would be an example of a permanent fastener?
Welding?
Okay, welding. Okay, certainly. Welding is considered a temporary or permanent fastener. Now, welding, when we talk about that, you're probably thinking metal, right? And certainly, metal welding is a huge component. But folks, we weld about everything. We weld plastic, we weld glass, we weld, you name it, we weld it. In essence, really, welding is heating a surface to turn it to a liquid state, adding some type of filler usually, and then letting it cool back as one homogeneous unit. Yeah, in fact, I'll bet you there's a lot more plastic welding that goes on in the world than there is metal welding. A lot more. Electricians, they weld every single day. You call it a heat shrink. Every one of their fittings is heat shrunk. And that's how they protect those. Now, certainly we've got a large part that's metal. They're right across the thing. You've all been in their lab. Sean's part of that process. Okay. So we do have that going on too. But whatever you weld, you have to destroy it to get it back apart, right? You pull out an acetylene torch and you cut it back off. So yes, that's permanent fastening. Any others?
There's ones that are barely big enough to fit into the, I don't know what they're called.
They're actually not big enough.
Oh, not big enough, yeah.
Fits, we call it a friction fit, right? An interference fit is what we really talked about, but it's really kind of considered a friction fit, where we have a device that's bigger than the hole it goes into. We mechanically join them so that it removes material off of both of them, and that's considered a permanent fastener. A lot of gears are installed this way, okay, on shafts.
So what about the plumbing parts, PVC, the one that's actually smaller, they glue it?
Okay.
It's not, they're not
So-
forcing it, so it's glue.
Permanent fastener, but you use
Glue.
many glues are a permanent fastener. Missy, you had your hand up. Did somebody steal your thunder,
Oh, I'm
thunder
sorry.
there, or?
Oh, no, I was just thinking a temporary is like the nut and bolt, like the washer that has the threads.
Okay, yeah, so temporary, we got threaded fasteners, right? That's over here. What other permanent type of fasteners do we have?
Oh, like the flex seal stuff. The flex seal,
The flex what?
like stuff they spray and it like seals it.
That's more of a glue, right? A glue adhesive? Is that what you're thinking of, one?
Yeah.
I need to get some of that.
So, yeah, some of that spray-on stuff, in essence, that's just an adhesive, right? So we call that a glue.
Would tape fall under glue also?
It may. Yeah, I think tape would probably go both ways, because tape really uses an adhesive, right? That's already coated on something. But some tapes you do have to destroy to get back apart. like Gorilla Tape, which is kind of a knockoff of duct tape. But you put that stuff on and leave it for a day, and you're probably not getting it back off without destroying it. I think that's actually a pretty good one. There's one other, we got some castings that will fall in that category too.
So when they said soldering obviously is welding, what's brazing?
Brazing is a welding technique also. It's just using copper flux,
Oh.
but it's a welding situation. Brazing is only done on copper. You've heard plumbers talk about, I gotta sweat the pipes. That's brazing.
Oh.
They use low heat because it's got a very low melting point. How about temporary? Missy's already got threaded fasteners, which is one. Yes.
The fan belt, you consider fastener?
Belts, you bet, they're fasteners. Okay, belts certainly are fasteners.
Hooks?
Okay. Yeah, we do hooks. Not on many machines, but
Well, those little T-pins and those things.
yeah, so those would actually be called
Have those in the mud buckets.
clips. We use a lot of clips. Where we'll cut holes, we'll stick one piece through, stuff like that. There's all kinds of clips. And in fact, Juan's drawn a clip. I saw him working on it this morning. He's got a clip holding his clothespins together. Would this guy fall into temporary also? Yeah, you bet. So we have our glue here. Would this one fall into temporary?
No. No.
Except for a couple. There are a couple that do. Brazing is one.
That's temporary?
Yeah,
You
it
heat up and
can
comes
be
right back?
considered a temporary fastener also. Because you can reheat it back up and remelt it. Now you're destroying the fastener, but you're not destroying the part. Okay? So a lot of these will go both ways. Yes.
What about just hammer and nail?
Nails
Okay,
temporary.
a nail is considered a temporary fastener. Certainly. Nails, we could call those pins, things like that. Unless you're using galvanized, galvanized nails. A guy had a lot of fun with me one day when I was a young person. Have you ever dealt with galvanized nails?
Uh-huh.
Well, they're virtually impossible to pull out. They're a special nail. And the guy said, oh, he's just kind of playing, drew it growing out. Hey, pull that nail out.
Big crowbar.
I was sitting there honking on that thing, couldn't get out. The friction on those just won't come out. I ended up ripping the head off of it and destroying the fastener. So there it was a permanent fastener.
And the drywall, the drywall anchors too are pretty much.
Yeah, anchors would be another one in here.
What does
And
that
we
mean?
use anchors, drywall, concrete, all those types of things we have anchors for. That's probably a pretty good list, but the point being, you've got a lot of different options here. You could consider a rubber band a temporary fastener. Twist ties on a bread sack. There's a lot of different things. So if we need access or maintenance, for some reason, then we're probably going and figuring out some type of temporary fastener for the method. We have a bunch of ways out there to do it already. If we don't want to provide maintenance, we don't care, we're just going to take the part, if it breaks, throw it away, put a new one in, then we're probably going with a permanent type of fastening method. Okay? Because we don't need maintenance, so let's just not have the chance of a breakdown. Let's just temporarily or permanently fasten. So it's a decision you got to make when you're joining parts. That's being the point here. Without a doubt, probably the number one temporary fastener is this one right here. Without a doubt. And in fact, I think that's brought home the author. What's the very first line of his book, or this chapter? If you look on page 908, look at the very first line the author throws out there. On the introduction. this kind of followed suit here. Fastening devices are used to hold 2 or more pieces together and are used on nearly every manufactured product. And it doesn't matter if you're doing electrical, architectural, mechanical, civil, whatever, you will be dealing with temporary fasteners, namely nuts and bolts. Now, when we talk about those things, first we ought to probably deal with, well, before I jump into that, chapter 19 has a bunch of different ones. So it's mostly got threaded fasteners up through, let me just kind of give you the page numbers here, up through about page 937, and then it switches to a bunch of others like rivets, which are considered a permanent fastener. You got all your clips, your springs, your washers, springs, all of that towards the end of the chapter. We're going to focus only on the threaded fasteners, but make sure you're aware of that other stuff because you may have to draw it and how they're represented. Now, when we talk about threaded fasteners, some of the history of it. It was first developed way, way back when, right around 0 BC. It was used in augers. I think the earliest that we've been able to determine, at least the history that research I've done on it, shows that they were using it in Egypt. And they were trying to pull water out of the Nile up onto the delta to irrigate it. And they used threads in a cylinder as an auger to bring up water from the river. Now, it's gone on quite a bit of other things from it, but first off, a thread, and let's kind of look at one real quick. Let's go to page 911. And we'll spend a lot more time on this page tomorrow, but this gives us a good look at an external thread. This guy right here. The shape that's formed by the teeth is called a helix. Now, a helix shape is kind of a unique shape. It's a tough one to represent on a drawing because a helix is a two-directional 3D object. It's moving at a linear and an angular rate around a cylinder at the same time. So as it comes around the outside of this, it's got to move at an angle or around, and it's got to move at a linear rate, which is across. And it performs that shape. Another way to think of it is, like if you take a ball of string and you hold on to one end of it and then you throw the string across the floor, it continually unravels, right? And so it's always traveling at that same rate. It's the exact same principle. We called it an involute back in drafting 131 when we drew our initial shapes. Remember taking your triangle and going 90 degrees and then you make it a new radius and go another one? We were trying to represent that. You don't draw these exactly. We do an approximate when we draw them. It just takes us too much time to get them exact. So you're dealing with a helix. Some more history. Leonardo da Vinci used threads extensively. He's made the first thread cutting machine. It only made one thread and then it broke down, but it's in the history books as he made one. He actually designed a helicopter. I think most of you probably are aware of that. That's a pretty common historical fact. And the rotors up above, he used threads on it. Again, couldn't get it to work because it would spin off the threads, right? They needed different technology other than threads to run that rotor. But that was his choice for it, to try on. The important one I want you to remember is a guy named Joseph Whitworth. Joseph Whitworth. He did the first standard thread. Now when we say standard, what do we mean by that? We mean a thread that was built to tolerances. We could replicate it. Up until Whitworth came along, every threaded fastener or nut and bolt that you had was paired. They were made by blacksmiths. So if you had a covered wagon and you're coming across the prairies and your hub comes off of your axle, you didn't fix it. You basically just threw the axle away because you couldn't buy another wheel that would thread on. Okay, the threads wouldn't match up. So you'd throw the thing away and somebody'd have to make a new one and they would make the thread right there on the spot. Now we all have coffee cans full of nuts and bolts in our garage, right? Right? And we go in and say, oh, I got this thing, I'll go sort through here and I'll find one that matches. Okay, well, we didn't have any of that until Whitworth came along. He developed that, and then a guy followed up on that, and Whitworth did, let's see, and we're going to look at page 911 again. And there is one thread on here, I gotta find it. Yeah, it's the Whitworth standard, number G, over here on thread form. Try and show this up here. See where it's got that 55-degree internal angle in the threads, right here? This was the Whitworth thread. So this was our first standard one. Now it was a round thread. It's still used kind of today, but it's been adapted for a knuckle. Knuckle is a sheet metal thread. We'll talk about these tomorrow in more detail. But the thing is, this was your first one. Now, this tooth broke a lot. So in essence, a guy named Sellers came along and he developed a 60-inch thread, which if I look at the very top form, the sharp V, this was a Sellers thread. Now this one came along right after World War I, when we really had mass production going on. So that was the big one, is the sharp V. Now this one had some serious problems with it also, is that when